Thanks for having me, and also I'd like to take this opportunity to thank BITS for the Lima Rosenthal Prize, which is really a tremendous honor. I would like to tell you a little bit about the work that we actually received this prize for, and it's called statcheck, and it's a software tool to, as it says, find misreported statistical results in published papers. To give you an idea what I talk about when I talk about misreported results, I have a small example here for you. So this is a paragraph that I copied from a published paper in psychology. And it doesn't really matter what it's about, but I'll read a part of it with you. So it says, simple effects analyses within each of the two levels of valence were conducted, revealing a significant main effect. So note that they think that they found a significant effect of subtype upon the proportion of positive words falsely recalled. And then you see the numbers that they back their claim up with. And this is basically a standard F-test that is used in psychology all the time. It consists of 3 parts. Degrees of freedom says something about the sample size that was used, the test statistic itself, and finally the p-value, which is probably the most important statistic in psychology, or at least that's the way it's treated. The interesting thing about results like this is that they are internally consistent. So it consists of 3 parts. If I have 2 out of the 3, I can calculate the third. So that's what we did. Based on these reported degrees of freedom and test statistic, I recalculated the p-value, and it's actually 0.06, and not 0.05, and not significant, as they make it out to be. So this is what I would call a misreported result, or at least a statistically inconsistent result. And before I go on, I would like to sort of make a distinction between 2 types of inconsistency we consider in our work. And the first type is just an inconsistency, and it does not affect the statistical conclusion. So an example would be a p-value that is reported to be 0.21, but upon recalculation, it turns out to be 0.20. This is an inconsistent result, but it doesn't really bear on the conclusion at all. On the other hand, you have the gross inconsistencies, and those do affect the statistical conclusion. So for instance, a p-value, just as in the example, that is reported as significant. So smaller is 0.05, smaller than 0.05. And if I recalculate this, it's actually 0.06. Note that this can also happen the other way around. A gross inconsistency would also be a p-value that is reported as being non-significant, but upon recalculation, it would be. So this is about terminology. The question would now be, how often does this happen in psychology? And if it happens often, what can we do about it? So to that end, I would like to have 3 main things I would like to talk about. The first thing is the method we used to answer this question. The second is to show you actually what the amount of misreportings are in psychology. And the third is I would like to share some developments and future directions we're currently working on. So about this method. I'm hoping none of you has ever tried to recalculate p-values by hand. Because it's not only very tedious and boring, it takes a lot of time, and it's very prone to human error. Because especially if you have this bunch of journals, bunch of articles that you have to work through, at some point you just are prone to miss some of these p-values. And because it's a fairly simple question that you're asking of the data, and that you're asking of these articles, we thought it would be nice to sort of automate this procedure, not only to be able to scan vast amounts of literature, but also to make sure that our inclusion criteria, for instance, are very clear, and we sort of eliminate the human error part here. So that's what we did. And together with Sascha Epskamp, who I think has fled the room. Sascha, where are you? No, he left. Well, he played a major part in this. And we developed the R package statcheck. And statcheck is actually a quite simple algorithm. It consists of 4 steps. The first step is that you want to convert an article that is usually in PDF or in HTML to plain text. Once you've done that, you're going to extract APA-reported null hypothesis significance testing results. And the fact that they're APA-reported is actually quite important in this kind of research, because statcheck looks for a very specific combination of letters, numbers, parentheses, equal signs, things like that. And the advantage of APA reporting style is that they are very specific in how statistics need to be reported. So that is what statcheck looks for. And luckily, APA reporting style is used all over psychology. So that's why we checked out the reporting errors in psychology. So once you've extracted these results, what you can do is you can extract the numbers, and based on the test statistic and degrees of freedom, you can recalculate the p-value. And finally, when you have a recalculated p-value, you can compare it to the computed p-value and see whether these are consistent or not. So there are a couple of assumptions underlying these steps, and there's two things that I would like to go into in a little bit more detail. For instance, in step 3, recompute the p-value based on the test statistic and degrees of freedom. Note that there's quite a strong assumption underlying that, namely that if there is an inconsistency, that it is in the p-value, which we don't know. The only thing we can tell is that somewhere in the 3 numbers, something is off. And we're assuming that it's a p-value, but we have no way of knowing. And one example would be this result. So this is also a paragraph from a published article, and I won't read it with you, but if we focus on this result, you see an F value here of 0.03 with a p-value, reported p-value smaller than 0.01. Now, I don't know how often you use F-tests, but if you have a slight feeling for these types of statistics, you can see in a glance that something here is off. And as a matter of fact, if I recalculate this p-value, it's actually 0.86. So I was actually quite puzzled by this result. Like, how could this possibly have happened? This is a huge error, or there's something really wrong here. How could this possibly have happened? Well, I still don't know, but there's actually one very simple explanation. It could be just a typo. Because if this F value was actually 10.03, the p-value that they reported would have been correct. So that is something to keep in mind the rest of the talk. That I'm assuming that p-values are off, but that's not necessarily the case. Another thing that is important in this algorithm is we are trying to compare computed and computed and reported p-values. There's actually a very obvious reason why these two might not match, and that would be if a p-value is reported as a one-tailed test, because then the p-value would be twice as small as statcheck would expect it to be. We didn't want to count everything sort of correct if it could have been one-tailed. Also because we have the feeling that one-tailed tests are often used to make a result look nicer, and it's often not mentioned. So we thought, well, if people mention that they are performing a one-tailed test and then report a one-tailed p-value, then we should make sure that statcheck doesn't flag this as a possible error. So what we try to do is sort of come up with this little trick. We say that if a p-value would have been correct if it was a one-tailed test, and somewhere in the text we can find the words one-tailed, one-sided, or directional, then we will say this was probably a one-tailed test and we will count it correct. So those two things are sort of underlying this whole process. Since this is automated software and a machine is always more stupid in a sense than a human, there are obviously some limitations to this software. The most important thing probably to mention is the inter-rater reliability here. We compared the results of statcheck with the results of a manual check, and we found that there was a 0.76 inter-rater reliability for inconsistencies and 0.89 for gross inconsistencies. So that shows that the algorithm is not perfect, but it's doing reasonably well. Some of the main problems we encounter right now is that statcheck doesn't find everything, because it's very rigidly looking for APA reported results. So for instance, everything in a table, everything in sort of full sentences, everything not following this strict reporting style will not be found. So in total, it's about 60% of the stats that it does find. Then there's currently kind of a discussion going on whether corrected p-values should be flagged as possible inconsistencies. If you, for instance, perform multiple tests and you want to correct your p-value for that, or at least I'm saying correct your p-value, but technically you should actually correct your alpha. But what people often do is they correct their p-value. So they perform 20 tests and they multiply their p-value by 20, for instance. If they do this, then the p-value doesn't match the reported test statistic and degrees of freedom, and it will be flagged. And that is something to also take into account, that statcheck does not recognize these corrections. And of course, since it's software, I mean, we've been working on it for 5 years now, but there will definitely be some bugs left, because that's just how it works with software right now. It's working quite well, but it will not be perfect. So this is Just a side note, something important to keep into mind. However, we thought basically based on this validity check, this reliability check, and these inter-rater reliabilities, we thought it was good enough to search the literature. So that's what we did. And we wanted to sort of document the amount of reporting errors in psychology. And we downloaded over 30,000 papers to scan. And we found 16,000 psychology papers that actually contained results that statcheck could find. In these 16,000 papers, we found that half of them contained at least one inconsistent result. And as I said yesterday, that sounds very dramatic, and this is also something that the media seems to have picked up, like half of psychology contains errors. It's not quite as dramatic as that. Most of these errors are somewhere in the third decimal, not influential at all. You could say it is sloppy, but I wonder how important this actually is. What is more important, I think, is to see that in 1 in 8 articles, there's actually at least one gross inconsistency. So an inconsistent result that could actually change the scientific, or the statistical conclusion, I should say. This is a thing to worry about, but you could still say, well, if it's sort of random error and it happens in both ways in the same rate, then we're still not in that much trouble. Well, I can immediately tell you that it's not random. We find that there is more often, in these gross inconsistencies, it's more often the case that a p-value is sort of rounded down towards significance than the other way around. And it's hard to say why this is. The 3 things I could come up with that are likely reasons for this is, well, the first that could be that it's actually questionable research practices. In a survey among, I think, 2,000 psychologists, 22% of them admitted to have rounded down a p-value from larger than 0.05 to smaller than 0.05 at least once. So that could be it. I think a probably more plausible cause is publication bias. So say that these errors are actually random, but only the significant results end up in the literature, then you get this disbalance in these errors. And a final reason could be a double standard in checking results. So you only double check your results if the mistake that you made in your reporting error, in your reporting, is not in line with your hypothesis. So if you find a non-significant p-value and you're like, wait, I was expecting that my hypothesis would actually show to be true, let's double check my analysis. Oh wait, yeah, I did write something up in a funny way, I should correct this, but it doesn't happen the other way around. But this is just speculation. I think we did sort of manage to point out quite a large problem in psychology, or at least a very common problem. So then we started thinking, like, what can we do about it to solve this? Because it might not be the most important problem science is facing right now, because we have this whole reproducibility crisis, flexibility in analyses, but this seemed sort of an unnecessary problem. So we were thinking about ways to solve this, and one of the things that I'm very happy to announce is that we now have a web app that you can use yourself. So statcheck was already available as an R package, but now it's also available on the web for people who don't know how to use R, for instance. And it's a very simple tool where you can upload a paper and it will give you back a table with all the results it could find and whether these were consistent or not. So I have to thank Sean Rife from Murray State University for helping me out with building this app. So this is sort of at the level of the authors themselves. They could check their own manuscripts before sending it into a journal. Also, a way of preventing scientific or statistical misreported results is through peer review. And Psychological Science is actually currently running a pilot study where they incorporated statcheck in their peer review process. So every paper that is not immediately desk rejected will get put into statcheck, and this report will be sent to an action editor, and who will communicate it to the authors to see if they can either explain why their p-value is inconsistent, because there might be a very good reason for it, or that they have a chance to fix it so it doesn't show up in the literature and you don't have to send in an official correction, which I think is a very nice way of preventing this from happening. We're currently also talking to Elsevier to see if they have journals who would be willing to participate in this, and we also hope that PLOS ONE might follow soon. There's one other way that statcheck could be used, and is being used right now, that also caused a lot of attention in the media. And that is because of my colleague, Chris Hartgerink, who scanned 50,000 articles with statcheck and posted the results on PubPeer. And PubPeer, I don't know if everyone is familiar with that, is sort of a scientific forum for post-publication peer review. And this had kind of mixed reactions, so to speak. Some people were actually, kind of happy that things were pointed out to them and they got the chance to fix their p-values, or they reran their analyses, or they fixed their errors. The problem is that since statcheck is not flawless, there were also reports on here that where statcheck made a mistake. And that sort of sparked this debate, and also some annoyance and sometimes even anger from some researchers who got really annoyed that their papers were flagged on PubPeer for no reason, which I can understand that would piss you off. I think that we are not quite there with figuring out how statcheck could help in post-publication peer review. This was sort of one experiment. I think Chris is also working on trying to figure out how he can make this work in such a way that it's less, that people find it less offensive sometimes. But that's a work in progress, and it's still figuring out a right way to use it in this sense. So for now, I think the main future directions I see are that we would really love to expand to the medical sciences and also other scientific fields to see what the state of reporting errors are there, which is quite complicated because they use different reporting styles, so there are mainly technical issues there, but I hope to solve them soon. We would like to expand to more journals to see if they could use it in peer review, and also maybe try to come up with a randomized study to see whether this actually has some influence on not only the reporting errors, but maybe also the overall quality of the analyses. We would like to improve functionality in the web app because it's pretty basic right now, but that seems a very simple future goal to have. And we would like to build a statcheck 2.0, which has a more flexible way of searching for results and recomputing these p-values, and maybe even try to come up with potential causes for misreportings or inconsistencies. So with that, I would be very grateful for your feedback, and if you have any bugs or any questions or any suggestions, please let me know so we can incorporate it in future versions.
Thanks so much, and again, congratulations on all the work here. I do have one question of interpretation, which is when you, in the 12.9% of papers with the gross inconsistencies, and maybe it's in stuff you've published and I've missed it, but what does the distribution of the errors, let's say if you focus on p-values, what is the typical sort of gap? And what I have in mind is just the idea that if you were talking about rounding errors, so just in a statistical sense, if people were claiming a p-value of 0.056, or they were claiming 0.049, but it was really 0.056 in only 1/8 of papers, well, then I would say, gosh, that's then the reporting in psychology isn't so bad. If there were, massive errors, I'd be more concerned. So I'm wondering if you could say more about that.
Well, there's actually one recent paper that Chris and I and some colleagues of ours published in which we were investigating this bump around 0.05 that is often mentioned, because the idea is if there's p-hacking and especially optional stopping and data peaking, and people will stop their analyses once they reach the threshold, you would see sort of an increase in p-values just below 0.05. And it is something we see in reported p-values, but not as dramatically as some people have found. The interesting thing is that it disappears if you look at computed p-values. And there was a lot of evidence that there was actually a lot of these small rounding things going on. And to come back to your second remark, whether that is a bad thing or not, I think statistically speaking, it is not. I think it doesn't really matter whether a p-value is 0.051 or 0.049. What I do think is important that it indicates something about the publication culture that we're currently in. So that, I think, is the main thing that concerns me about these results.
Hi, I'm Elizabeth Seaver. I'm a researcher at PLOS. So great talk, by the way, and we think a lot about this sort of thing in scientific publishing. I'm wondering, When you described the workflow of PDF to plain text, it just kind of broke my heart a little bit. And I'm wondering, are there things that publishers could do to make it easier than crawling plain text for representing statistics?
You mean easier for statcheck to read them?
Yes, and for people to double check them for reproducibility reasons.
The easiest thing would be, well, I mean, the whole problem with PDFs is just a very technical one that sometimes in copy editing, for instance, mathematical symbols are replaced by pictures of mathematical symbols, which really broke my heart. And my computer. But in reinforcing a reporting style that is useful for statcheck, I think it is very nice if this just APA style is just very strictly maintained. Because that is right now the thing that statcheck looks for specifically. Also, I think it is very useful, even if there was not such a thing as statcheck, because for instance, in some fields, for instance, I think in the medical sciences, it's way more common to only report p-values and not the rest of the result. Correct me if I'm wrong. I'm seeing some people nodding. Which I think is already sort of sending a wrong message. I would also very much encourage reporting effect sizes with your result, but from a statcheck point of view, I would very much encourage it to report them after your p-value and not in between the results.
Hi, Sean Grant, Rand Corporation. Great talk, really excited about this. I work in research reporting guidelines, so a bit of background, so you think I'm just a partial crackpot, not a whole crackpot, but I work with Consort, Equator, and the Registered Report Steering Group at Center for Open Science. And so thought, and then something I'd like to get your thoughts on from that area. One, for medicine, I'd say get in touch with the Equator folks and Penelope Research if you haven't, because Penelope in particular is trying to do what you're doing, but for research reporting guidelines in medicine and looking to integrate that with journals workflow. And then something to get your thoughts on. So as I think a growing number of people in this movement do, see all of these things, these solutions as behavior change interventions and trying to use the frameworks, theories, methods of behavior change interventions that we see in health, psychology, other areas to develop effective interventions and then scale them up. And I think for these types of interventions where you're looking in the research life cycle at the point of publication, while I imagine journals are interested in the quality of the science because journal editors are researchers by and large. One of the things in my conversations with Elsevier publishers, journals, is seeing in trials of these tools outcomes that would really convince journal editors to take these things on board. And in addition to accuracy, wonder if you thought about whether this speeds up the efficiency of the peer review process and the burden on editors and peer reviewers to review an article, because I think showing that you're moving the needle on that in some instances may be more influential in convincing journals and publishers to take this on board than just saying it improves the quality, though I think that is a necessary part of it as well. So I'd be keen to get your thoughts on that.
Yeah, thank you. I actually think that peer review is a very complicated topic because, it's sort of the best we have, but everyone agrees it's not good, and how are we going to make it better? I don't think statcheck is going to make the peer review process better as a whole, because I think it sort of adds something to it, because judging from the amount of misreportings that we found in literature, this is not something that peer review is looking at. I mean, that's an overgeneralization, but that's the feeling I get. So by having these kind of little tools, you could compare it with a plagiarism tool, but less dramatic, perhaps. So it's something that you cannot see, cannot see easily as a human, but as an automated tool, you could. I think to improve scientific peer review, we very much need a lot of empirical research about what kind of things help in creating the best manuscripts as possible. So for instance, these checklists of checking whether at least everything is reported. But yeah, I wonder if we could ever automate peer review as a whole. I don't think that's necessarily something that we should want.
I think I have a simple question that sort of is related to Ted's. So I'm just curious, does the presence of a reporting error, is it predictive of anything else? That is, So take the strong form would be look at the reproducibility project and say, are those papers which are more likely to replicate, do they have fewer errors? Or the ones that don't replicate, are they more likely to have an error? Something like that.
That's actually a very good question, which a colleague of mine is looking into right now. So I hope to have that answer soon. From the research we did, I would not be able to really conclude whether it's correlated with anything. We're trying to see if there's a correlation, for instance, between reporting errors and open data, with the hypothesis that people who share their data have fewer reporting errors. So far, there doesn't really seem to be an indication that there's a relation between these two things. What I do know is that in the survey research of John et al., they did find a sort of a curve that if they ordered the questionable research practices, they asked researchers whether they've done it in some of their research, and we're following this scale that if you admitted to something relatively bad, you probably also admitted to things less bad. And these were kind of reporting errors were somewhere in the middle of the severity scale, so to speak, which you could speculate then is an indication that people who misreported a p-value also may have, for instance, not have reported all their dependent variables or did some other form of p-hacking. But that is very speculative, and I don't really have data on that. But that is really something that we would like to look into further.
All right, we'll take two final questions, so Ed and then Adam.
So what comes to my mind is the question of materiality. Are these just typos that don't have a real impact on the conversation that comes after reading these papers? Or are they influencing that in some way? So you say predictability. One thing you could look at is citations that come later. Are these errors helping the papers attract citations that they don't deserve?
I don't know, but that is a very interesting question. Because my gut feeling would be that papers with that show larger effects, that show more flashy conclusions would attract more citations. I wonder if a reporting error like this would be a big enough effect that it could actually affect the number of citations. I think that if there is a relationship, it would probably be very small, I hope, at least. But that's definitely something to look into.
Thanks for this tool. It's really cool. I probably should add statcheck to my model and see how it predicts replication in that.
Yeah, please let me know.
I was thinking about a different thing. Like you're talking a lot about the peer review process as a place where you would use this, but I myself as a researcher, I think I would love to like somehow automatically whenever I run my code or like whenever I compile my LaTeX document, just let statcheck tell me, oh wait, you have some errors here. I think, couldn't you add something like that? Wouldn't that be useful?
I think that would be very useful. That's also one of the reasons we created this web app. That is not as integrated with, for instance, LaTeX or NetR or other forms of integrating analyses with your document, but that is definitely something to look into. I do know that there is a similar program, it's called Penelope, and it checks Word documents, like manuscripts, for basically everything. So whether your tables refer to something in the text, whether you have all your references both in text and in your reference list, whether if you're doing some animal research, for instance, whether you're saying something about ethics, but also they're checking internal consistency of stats. And it's a pretty new project, so I'm not sure how advanced their internal consistency checking mechanisms are. But I think it's a very promising line of research to make it as easy as possible for researchers, basically to have this little spell checker in Word underlining things that might not add up.
There is like in programming, there is a tool or tools called linters, which basically check your code while you're writing it. You could, it would be, I think, pretty easy to let such a program just run statcheck on your code while you're writing it. And
oh, that's actually a very good idea. I'd never heard of that. That's a good suggestion. Thank you. Thank you very much.